So, welcome to this lecture of machine learning training program, and in this particular lecture we are going to talk about kernel trick. Okay, we're going to talk about kernel trick. So basically, first of all, let's take a very simple data set to understand kernel trick. Okay, you have to focus here because a lot of things is going to be coming here this time. Okay, you have this particular graph, let's say. Okay, and I'm just taking this line for a reference for now. And what I'm going to do, I'm going to plot some points here, not like this here. Okay, I'm going to do plot some points, which is this one. It's way too more. Just a second. It is going to be this one. Okay, and it is going to be this one, we can say, and we can have the points as. Okay, I have really taken a very long line, but still, this is this point and this is the point. Okay, and let me remove the line first of all. I'll tell you what I'm doing here. I'll tell you. Okay, so you're having this data here, these four data, which is red, green, and two reds and two greens, and I want you to divide this data into two parts using a straight line. Try that in your copy. If you're making the notes, make sure that you're making the notes. Please don't watch the video just like you're watching a movie. Okay, make sure you are taking the notes. So basically, if we try to divide a dataset into two parts using a straight line, it is quite impossible to do that. It is quite impossible. There is no way we can do the divide the dataset into two parts using a straight line. Because see, we are having these 4 points in the straight line. This is the straight line. Okay, so that is why we cannot divide the dataset into two parts using a straight line. So that's for sure. We cannot use straight line for now. Okay, so if I ask you three questions here. If I ask you three questions here that tell me that if you have three equations as an answer, let's say, just a second, I haven't selected the pen. So let's say you are having three equations, let's say x plus y, xy, and x square. What is going to be answer here? What is going to be help, or which of these three equations is going to help us to get the answer? What do you think? Okay, xy, what do you think that? Just answer yourself. Okay, so basically to know this answer, to know this particular answer, what we need to do, we need to first of all, take care of, we have to make a table here. Okay, we have to make a table here. How the table will look like, let me tell you. Let's say these are the data points as let's say this is the 0, 3. Okay, this is 3, 0, and this one is, let's say, 1, 2 or something, and this is going to be 2, 1. Let's say this is the straight line. That is why we are taking this this data as these points. And now if we make a table out of this, if we make a table, that means this is 0, 3, and we are going to have 3, 0, and we are going to have 1, 2, and 2, 1. These are the four data points we have, and we have the equations as x plus y, xy, and x square. These are the three equations we have. So let's try to implement these. For x plus y, 0, 3 is going to be 3, 3, 0 is going to be 3. Okay, and x plus y, this 1, 2 is going to be 3, and 2, 1 is going to be 3 simply, right? And for the xy, this one is going to be 0, this one is going to be 0, and we are going to have this one as 2, this one as 2. And for the x square and for the xy, this one is going to be 0, this one is going to have 9, and this one, these green ones are going to have 1 and 4. This is how your data set will look like. This is how your data is not data set. This is how your table will look like once you implement it. So as you can see, it is x plus y is equal to 3 we are having. So that means it's a straight line. So at x plus y equal to 3, we have to draw a straight line here. Just a second. Let me remove this first of all, and let's grab the straight line. Okay. So it is going to grab a straight line at the x is equal to 3, let's say. Okay, this is the 3. Okay, this is the 3 we are having. Okay, x is equal to 3. So that means x is equal to 3 is not going to help us to divide the data because it is still misclassifying the data into two parts. It is still misclassifying the data. Okay, so that is why let's answer the x square. X square is going to be a parabola like this, maybe somewhat like this. Okay, at x is equal to 9, if it is going to have, so it is going to have way more, this 9 is going to be, right here. So we cannot do that. So maybe the x, the parabola maybe look like somewhat like this, and still it is not dividing the data set into two parts. So we take for the xy, and now xy, okay, let's take the xy, and xy is having lowest number as 0, and xy is having highest one as 2. Okay, and as you can see in the table itself, that it is properly dividing the data, into two parts. One is the 0, one is at the 0, and other one is at the 2. So xy is equal to 0, xy is equal to 2, and that means xy is equal to 1 is going to be a solution, because lowest one is 0 and highest one is 2. If let me do one thing. Let's remove this, and I'll say xy is equal to 1 is our answer. So this equation can be written as y is equal to 1 by x, and 1 by x represents the hyperbola. Okay, it represents the hyperbola. 1 by x represents the hyperbola. So if I make a hyperbola like this, let's grab a pen, and if we make a hyperbola like somewhat like this, this is going to be our division. This is going to be perfect division. That means now it is properly dividing the whole data set. Now it is properly dividing the whole data set here. Okay, as you can see here, we are having the red portion, and here we are having the here we are having the green portion, and here we are having the red portion. So now, as you have seen the whole division of the data set using a hyperbola, what if I tell you that there is another solution to this also? There is one more solution to this. Let me show you. Let's say if I want to have this solution in the 3D form, this particular solution in the 3D form, not this particular solution, all these data points, I want them to be plotted in a 3D plane or three-dimensional plane. Okay, so I want to do that. So let's say these are the data points. Let me tell you how we're going to plot that. Let's say these are the data points, which is 0, 3, and we have 3, 0. Okay, we have 3, 0. And we have 1, 2, and we have 2, 1. These are the 4 data points we have, and these are x, y, right? These are some x, y. We can say that we have the x, y. So let's say these are x, y. I want to convert them into x, y, z or something. I want to convert into x, y into z. Okay. So basically, if I want to convert them into x, y, z, I want a z axis there. We cannot plot 2 points. We cannot plot just x and y on 3-dimensional plane. We need some z axis there. We need some z point. So again, we have 3 options. Which is what? X plus y, and we can say x square and xy. We want these. What you can do, you can try these two on your own, and you will find out that these are not the solution. This is the solution we are talking about. Okay, so I will be plotting the xy. You'll plot x plus y and x square. Try to see, but I'm telling you that these two will not work. Why I'm telling you? First of all, let me tell you why it will not work and what is the aim we are trying to achieve. So let's say this is our axis. Okay, this is our axis we have. Okay, this is z axis. Again, this is the z axis, and this is the x axis, and we need y axis, right? So let's say this is the y axis. This is a 3-dimensional plane, right? This is the y axis. Okay, and when we're going to plot our data points, let's say at this point we are going to have a plane there, right? We're going to have a plane like this. We're going to have a plane like this, okay, which is going to contain x, y, z. Let's say they are going to get containing the red points and the green points like this. And if I'm able to pull these green points or the red points into separate plane, that means this is the, let's say this is the another x-axis. Okay, this is the another x-axis, which is this. Okay, x-axis, and this is y. Okay, and again we are going to have a plane there. somewhat like this. Okay, this is what a plane will look like. And if I'm able to pull these green points here, okay, if I'm able to pull these green points here, and if I fit a plane in between like this, okay, again let's have a straight line. Just a second, sorry for this. Let's grab a straight line here. If I have a straight line, and not this is a straight line, this is axis, which is the x-axis, this is the y-axis, and if I put a plane in between to divide these data points, it means if I put a plane in between, cutting the whole thing into two planes, green points are going to be on the separate plane and red points are going to be on separate plane. If I'm able to do that, I will be able to divide the dataset into two parts, right? Because the green points are going to be on separate plane and red points are going to be on separate plane. So that is why if we are able to find a solution that if these green points are going to be on separate plane, if we are successful to bring these green points in a separate plane, we are able to divide the dataset into two parts. Okay, so basically that is why I am saying that try xy as a solution as a z-axis. That what I'm trying to say here is, if I remove this z from here, and if I put the solution as xy, okay, this is our solution. Just a second. This is our solution xy as the z-axis. You can try x square and x plus y also. It will not work. You try to plot it, but in the end xy is going to work, because I'm telling you how. That if we take about 0, 3, it will look like 0, 3, 0. For 3, 0, it is going to look like 3, 0, 0. And 1, 2 is going to look like somewhat like this, which is 1, 2, 2, and 2, 1, 2. Okay. So these are the xy values. These are the xy values we are having. Okay. So let's try to implement that. So let's do one thing. Let's remove all the points from here. Okay. Let's remove all the points from here. Okay. And let's try to plot it. So now 0, 3, 0, 3, 0 can be plotted as x-axis is the 0. Okay. Z-axis is the 0. That means 0, 3, x-axis is 0 here, as you can see. X-axis is 0. Z-axis is 0. Okay. And that 0 is going to be here, and y-axis is 3. So let's say y is going to come somewhat like here. Okay. X-axis is 0, y-axis is 0, and we are moving till y is equal to 3. So we are having this particular point here in the plane. So let's plot that point here. Okay. So this is what it is representing. It is representing us 0, 3, 0. Okay. Now if we plot the 3, 0, 0. Okay. Now if we plot the 3, 0, which is this one, 3, 0, 0. So it will look like x as 3. So on the x-axis it's 3, and for the y and z-axis it's 0 only. Okay, so that is why it is going to come somewhat like here, which is what 3, 0, 0, right? So let's put 3, 0, 0 here, 3, 0, 0, 0. Now let's put the green points here, 1, 2, 2 for the green points. So x is 1, y is 2, and z is also 2. So that means it is going to come somewhat like here, because z is also 2. So let's say the point is going to come somewhat like here. Okay, the same way 2, 1, 2, because 2, 1, 2. So x is 2, y is 2, and z is also 2. So let's say z is going to come here. Okay, z is going to come here. That means red points are on a different planes, which is having just y and x axis on a different planes. This one, this blue plane, and this particular, the above plane, the topmost plane is having the green points. And if I put the, if I cut the plane into two parts using this yellow plane, it is going to get the answer. If you don't understand this, let me tell you again. Okay, although if you don't understand this right now, don't worry about it. We are going to use that practically and mathematically. Don't worry about that. Okay, just rewatch the video 2-3 times. Whatever you understand, it's good. I'll tell you what you have to take away from this. So basically, if I talk about what exactly is happening, that whenever you are dividing the data set into two parts in a 3D, it is containing the 3D points like this. Okay, it is containing the 3D points like this. Okay, so what it is happening, that you have a plane here, you have a plane here, and you have all the red points at here, green points at here, and you are cutting this kernel, cutting this mountain into two parts. Okay, that is what it is happening in this particular area of kernel method. And what if I say that we studied about two solutions, which is this one, and plotting the 2D form and plotting in the 3D form. We have two solutions. What if I say that these two solutions are exact same thing? We are just increasing the dimension, nothing else. It is exact same thing that we are implementing. Why? Because whatever we are doing in the 2D form, exact thing we are doing in the 3D form, because we are using the same solution as an output, which is XY. We are using same solution as an output. That is why when we are having this XY, and when we are having the XY in the 2D form and 3D form, it is doing exactly same thing, just the dimension is different. So that is why it is, it is the exact same thing. The solution is having the exact same thing, whether you implement using curve, whether you implement using the plane. Okay, this method is known as kernel method. Remember this thing, and it is very much used in support vector machines, kernel method. Okay. So make sure that you remember this kernel method, and let me tell you what you have to take away from this. The first thing is, when you have the data points like these, or when data points are not able to divide it, we use kernel method. Sometimes we use kernel methods, and kernel method basically does it. It tries to find a perfect solution where we are implementing using XY there. So we are having this XY. And whenever we're dividing the data set into a hyperbola, using a hyperbola, that is called a kernel method. And study the process later on in the video again. Just watch the video again, you will understand this. Don't procrastinate on this. And we are having the 3D plane. That means we are trying to bring the green points on a separate plane, red points on a separate plane, and cut the plane in between, cut the whole kernel in between. And that is how we implemented the kernel method. Okay, just remember this thing. The cutting the plane and having a curve is the exact same thing we are doing it. The solution is exact same thing, whether you do it in the curve form, whether you do it in the plane form, we are doing the exact same thing. Okay, so that's it for this video, and that's it for the kernel method. And make sure you revise these concepts again, and we'll meet in the next video. We're going to talk about more algorithms in theoretically, and then we're going to start with the coding part. That's it. We'll meet in the next video.